My slides do not get any bigger, so if you're having trouble seeing them, you can follow along. You can follow along test-more.github.io/test2 manual. Yeah, these slides don't get bigger. They were made for an easier to see projector screen, unfortunately. Anyway, I'm Chad Granum, a CPAN handle exodist, and I maintain Test2, Test Simple, Test Builder, all that good stuff there. I've been doing that for a few years. So question, what is Test2? Test2 is the new framework that replaces Test Builder. This was done because Test Builder was really showing its age. It had had many years without any significant overhauls or changes, and a lot of things were being built to hack around it. The obvious question from that is, what's going to happen with Test Builder? Test Builder, for the past 2 years or so, has actually just been a compatibility wrapper on top of Test2. So if you have a modern install of Test Simple, you've been using Test2, whether you knew it or not. So let's look at some benchmarks. These are about 2 years old. I did not have a chance to revamp these. They've probably improved. But if you look at load times, using Test2 does take longer to load than using Test Builder. Test Builder would load in 0.010, and with Test2 you get 0.027, which is about 3 times longer. So Test2 does have a longer load time. But then you come down here and you look at the actual runtime performance, and Test2 absolutely blows Test Builder away. So the legacy Test Builder to run 100,000 OKs, 3.8 seconds. Test Builder on top of Test2, it's a little bit faster, 3.3 seconds. If you do just Test2 without actually loading Test Builder, that drops down to 2.3 seconds. Then IPC performance is improved as well. With Test Builder, you could only do threads for IPC. Running 10,000 or 100,000 OKs, even if you're not actually using threads, would take longer at 5.3 seconds. With Test Builder, with Test Builder on top of Test2 using IPC, it's less of a slowdown, only 4.2 seconds. And if you use just Test2 without Test Builder and the IPC, you're still outperforming the original Test Builder without that had IPC loaded, or even without IPC loaded. So Test2 has a much better runtime performance. And
do you pay the penalty for startup per file?
You do. So yes, if you have a test suite where each file takes a long time to run, Test2 is going to be much faster. If you have a large test suite where each file goes really quick, Test2 will be slower. But it tends to balance out. Like the Perl 5 test suite itself takes about the same amount of time. So this talk is for all levels, so I'm going to actually start off with a basic testing tutorial using Test2, but then we're going to get on to some more advanced things. Before I begin, how many people in here have used testing tools like Test2? Okay, pretty much everyone. Who here has used Test2 directly? Still quite a few, but not everybody. Okay, so this tutorial is bootstrap into testing using Test2. So first, the boilerplate. If you're starting a test with Test2, instead of using Test-more or any of those, you just use Test2 : V0. This is a testing bundle that is my recommendation for what you should use for testing. And as more people are involved in Test2, this won't just be my recommendation, it'll be the community's. So it loads several things, which I'll be showing on other slides. So first thing with testing is that you need a plan. And a plan is important because it ensures all tests run. One of the big issues that plans solve is sometimes you might call a function that will exit 0, and your harness will go, oh, it exited 0, it's all good, even though the rest of your tests haven't actually run. That is the situation a plan is intended to prevent. There's a couple ways to plan. There's the old style that Test2 used to recommend, where you just give a static number and say, this is how many tests are going to run. In Test2, that's done with the plan function, as opposed to an import argument. There's a lot of reasons for that. It's a bit easier. But planning by typing out a static number is annoying. You have to maintain that number every time you change your test file. And if your tests are somehow a random number of tests because of various data, you might not even know what your expected tests are. So to fix that, a while back, TestSimple introduced the done testing function, which you call at the end of your tests, and it will output the plan at the very end. And if something exits early, you'll never hit it, the plan will never be output, and it still solves the problem to let you know you did not run all your tests. Another way to plan is to say, hey, I can't actually run this test right now, such as if your test won't run on Windows. You can do this first example here, where you just skip all the tests if you're running on Windows. Or if you're really crazy, you can have a test that can't run on Tuesdays. So you can skip all if today happens to be a Tuesday. I don't recommend that. That's code smell.
How about skip it, user ID equals Abigail.
There we go. So assertions. If you're writing tests, you're going to want to write assertions. The most basic assertion tool is OK. I'm pretty sure everyone in this room already knows how this works, but you give it a Boolean value and a name, and it's either pass or fail. Moving on, comparisons. So everyone who's used Test2 is also familiar with is, where you can do a string compare. With Test2, is deeply has now been replaced by is as well. So you only call is, you don't call is deeply. You can pass it deep data structures, like they were comparing to arrays. You can go even deeper and just compare two data structures infinitely deep. And overloading is handled by having the right-hand side determine what type of comparison will be used. So in this case, we've passed in an object as what we got, and a string is what we want. So what's going to happen is, under the hood, it's going to use a string compare, which means if overloading was done properly, this will just work. If it wasn't, you're going to get a string compare against the object's memory address, which hopefully will be an error. So yeah, right-hand side defining what the comparison will be solves a lot of the problems that initially required is and is deeply to be separate.
How do you tell the difference between a string 1 and the number 1?
It doesn't. For scalars, it always uses string compare unless you ask it for a numerical compare. Trying to guess between a string or a number is just batshit crazy in Perl. So like is also now a deep comparison tool. So you can do your standard like and string and a regular expression. Works just like you'd expect. You can also do a like on a deep structure. A like comparison is different than an is comparison in that it is relaxed. It'll only care about the things you ask it to care about. So if you do a deep comparison of an array with 4 items and an array of 2 items, it'll only check the 2 items it gave you, and it won't care that there's extra items in there. You can also deeply embed regular expressions in your comparison, and it'll just automatically treat those as, hey, I need to match against this. And once again, right-hand side defines what type of comparison it'll be. There's a DSL that will help you to define these checks and provides extra benefit of giving you the line number of the actual element in your deep structure that failed. So for instance, here we've got what we're checking again, or what we received and want to check. We're saying, hey, first item should be an X, or this is an array. First item should be X, second Y, third is a hash, it's got the field foo, it's got yikes. In this case, D&E means does not exist. So we're checking that the field yikes does not exist. And then end to say, hey, there are no other fields in this hash. We could do the same at the end of the array and say no more fields in this array. But we're using an is comparison, so the end is implicit. And obviously this is going to fail. Absolutely nothing in our array here matches our check. This is the diagnostics you get when you use this. It tells us that we got an array, so that expectation was met, but that within that array, the first item did not match. A is not X, and it tells us what operation it used. It tried to use the string equality operation. Same with B not being Y. We did find a hash, so that expectation was met, but then the things inside it didn't work out. And we get the line numbers on which these checks were defined, so you don't have to go and figure out where in your deeply nested structure those definitions were. This right here is the big thing with Test2, these diagnostics, let me tell you. Thank you. So to-do works a bit differently than it did with Test2. You don't have to localize a global variable anymore. So there's 2 ways to do it. There's the new style, where you call the to-do function with your reason and pass in a subroutine. And then anything inside that subroutine falls under the scope of the to-do. Obviously, that does inject a new stack frame, so if you're testing deep exceptions or warnings, that might cause issues. So there is still a legacy style to do, where you just create your own variable, not a global one, and assign the return of to-do without passing it a subref, and then that to-do will remain in effect until that variable is destroyed. Once it's garbage collected, the to-do state ends. So it works a lot like the local to-do from Test2, except it's not super crazy magical with global variables. So if you're using Test2, you're going to need to list your dependencies in your build tools. It's very important that you list them properly. You don't want to just list the basic Test2 module or Test2-Suite, which is where most of these tools live. What you should actually list is which bundle you are using. In our case, Test2 : V0. That way, if we later want to upgrade and make some changes because something wasn't right, we'll release Test2 : V1. New tests, you'd start using V1, but your old tests won't break from the incompatibility because they're still using V0. And if at some point we want to split those distributions, having required the correct version means it will be transparent to you that those are now separate distributions. So for Dizilla, the wrong way would be to list Test2-Suite. The correct way would be to list Test2-Suite V0. Maker is very similar. Here's the wrong way, and here's the correct way. So the what next is what we're going to go to. This is also available online as a self-taught thing, which is why the what's next is here. So I'm just going to skip that. So tools. Test2 defines several namespaces. The primary one you're going to be working with is Test2 tools and things that live underneath that. Tool is any function that produces testing events. And events are generated whenever you make assertions, set a plan, produce diagnostics, anything like that. And they, like I already said, they live in the Test2 tools namespace. Basic set of tools are your typical OK, diag, to-do, plan, all the things we've covered there. It's also pass and fail, which Test2 had, though many people didn't use them. And they work just like I've gone over in the previous slides. Pretty simple there. There are also tools for classes. Some of these you'll be familiar with, except they have changed. In Test2, is it OK and can OK looked like they were used the same, but they weren't. Is it OK would take, for its first argument, something to check, its second argument, something to check against, and then the third argument was an alternate name for the first. It was not a second class to check. If you've ever done that, you have bugs in your test suite. Can OK was totally different, even though it looked the same. It took something to check, and then a whole list of things to check that it could do. So they didn't match at all. In Test2, they have the exact same signature, so you don't make that mistake. First one's the thing to check, and then all other arguments are the thing to check against. Though recently there was a pull request, so there's a new behavior where if the second argument is an array, it will use that as a list of things to check, and then the third argument is your test name, which is a much requested feature that's pretty good. So right here listed as new. Comparisons we'll get to later. I have moved that slide. So Test2 tools defer. This is one that you almost never need, but when you need it, you really need it. This happens if you are making your own Test2 tools that you want to test, or plugins maybe that you want to test. And so you need to verify some behavior before Test2 is actually even loaded. Test2 tools defer lets you define some tests that will happen, and when you do, it'll capture all those arguments, but it won't actually run any Test2 logic yet. Then later on, after you've loaded Test2, you run do def, and it will actually make all those comparisons happen against the arguments it previously captured. Most of you will probably never need this, but it's useful when you do. Encoding.
Def instead of defer.
What was that?
Def looks like defined. I mean, why would it's just something you picked?
Just something I picked. So encoding. If any of you have ever tried to change the encoding when using Test2, you know that it is a royal pain in the ass. You have to modify your global file handles. You have to modify the global handles that Test2 conveniently copied for you in advance. And you have to do it all through a bunch of roundabout test simple way or test more ways. And it quickly becomes a nightmare, especially if you then go into subtests where they might have completely different file handles. With Test2, this is simple. You load Test2 tools encoding, set encoding, and give it your encoding, and it'll work, and everything will have that encoding. It was very hard in Test Builder, let me tell you. Exceptions. So Test2 has a tool similar to what Test Fatal provides, except it does a lot less for you. That is by design. So if anyone here has used test exception, you know that it can accidentally match against a stack trace because your arguments to the test tool itself will be in the stack trace. There's a lot of magic put in place to try and prevent that, but that magic sometimes causes its own errors, such as a bizarre copy of array at some line you didn't even know existed. So the new standard is to use something that will capture the exception and return it, and then test against that returned exception. It's slightly more verbose, but it is a lot safer. There's also a lives, which just returns true if you didn't throw an exception. You can test exports. This is a new tool that was not in test more. You can type imported OK and then a list of things, and it'll verify that those were imported into your namespace, which means it checks that they are defined, and that's pretty much it. It checks that they are defined in the current namespace. This is not inheritance, though. If you're a subclass of another class, it will not check if the parent class can do it. So you have to actually have them in your namespace for it to work. There's also not imported OK if you want to make sure they're not in your namespace. Checking references. There's a few new tools. There's ref_OK, which verifies something is a reference. You can also pass it a second and third argument to say, hey, make sure this is a ref and that it's an array ref. You can also do ref_is to check that two refs are pointing at the same thing. Then ref_is_not is the opposite. Make sure these are not the same ref. That's important because of the changes to is, where you can't just give it the same ref twice because it'll do a deep comparison instead of a check that they're the same memory address. Subtests. There's a new way for subtests to work. The default now is a buffered subtest, which will not produce any output until the subtest is done. And it looks like this. It's got these brackets, and the primary assertion comes first. This is done because there is concurrency in Test2. You might be running multiple subtests at once. And when that happens, you don't want their output to be all muxed together. So buffered subtests solve that problem. You can still use the old style, which is now called streamed, using subtest streamed. And that will output the traditional subtest output. Test more, if you're using that, will still default to the old style subtest for compatibility. Warnings, there's tools to help you capture warnings. It's similar to the dies, except there's more of them. There's warns, which just returns how many warnings you got. No warnings to make sure code didn't warn. Warning to capture the actual single warning, or warnings to capture all the warnings. It's a bunch of tools that are quite handy when you actually need them. Any questions about any of these tools before I move on to compare? Cool. So Test2 tools compare is where all that really nice stuff you saw a couple slides back is defined, with all the good diagnostics. And it provides quite a few tools. There's is, there's like, there's isn't, and unlike. And then there's a bunch of helpers, match, mismatch, validator. I'm going to get into all of these in later slides. And we've already covered how to use those, so I'm going to move on. So simple state checks. You can check that something is true, something is false, something is defined, something does not exist, or something is false or doesn't exist, you don't care. That's really helpful when you really don't care. You want this field to be false or not exist, you don't care which, so just false or does not exist. You don't have to modify it to make sure it's the right version of false, because Perl has a lot of falses and a lot of trues. So you got true, false, doesn't, that should be E, I think. Nah, whatever. Moving on. Sorry, I've got a cold and my head's a little foggy right now. So you can do directed checks to actually have deeper control. So normally you'd use like to use a regular expression on your right-hand side, but if you really want one in a stricter check such as is, you can do is foo match against a regex, or mismatch if you don't want it to match that regex. And someone earlier asked about checking whether it's numerical or string. It defaults to a string compare for sanity, but if you really want to check a numerical value, you do is 12.00 verify it's the number 12. It's just going to use a numeric comparison, so those will be equal even though the decimals are different. So you can do a numeric check, but you have to be explicit about it. You could also be explicit about a string check, but that's usually redundant. And you can also check that something nested in a structure is the exact ref you're looking for. You can do custom validators. They're complicated. I want to simplify them, so I'm not going to spend a lot of time here, but it lets you create your own version of, say, exists or does not exist, or is this an object I think it should be. Sets. Is apple in the set pear, apple, or orange? Yes, it is. There's also not in set. Make sure that apple is not in the set. Check that the value matches all of the checks. So apple has 2 P's, so it matches that regex, and it has an A, so it matches that regex. This lets you do some really complex checks on a single line there. Array checks. I've already shown you one example of this. You define an array with a code block, and you give it each item, and then end when you're done if you want it to. End is implicit with is checks. It is, but it is not with like checks. So that's a little complicated, but once you figure it out, it's really useful. Then you can also specify a specific index. So here we're saying item 0 should be foo, item 2 should match this regex, or sorry, 0 and 1, and then item 3, we're skipping item 2. We just don't care about item 2, but item 3 should be bat. Then here's a diagnostics to show just how much detail you get when that fails. Hash is very similar, except you use field instead of item, and it takes a key and a value pair. And once again, really nice diagnostics here. Meta checks. These are really useful too. You can do meta data about the thing. Check that the property is that it is blessed to this class, that it has this ref type, that it is of this size. So if it's an array, it's the size of the array. If it's a hash, it's how many keys are in the hash. This is a reference to the thing again, so you could nest this again and do another meta check or an object check or a hash check. Then object checks, very similar. We're passing in a blessed thing. We got the object. With an object check, you can use meta properties such as prop. You can use field if it's a hash reference, or you can use item if you've blessed an array reference. Or you can even call a specific method against the object and check the result, or pass in an anonymous sub to call against the object, which is what you might want to do if you've got a method that you want to check that returns a list so that you can wrap it in an array. Any questions about the comparison tools? Yes?
One thing I often find myself doing is trying to basically compare 2 arrays, but I don't care about the order.
Mm-hmm. So it's not on my slides because it's fairly new, but someone gave me a pull request that's been merged for a few months now that has the bag check as well. It's like an array check where you don't care about the order. It has some of the same flaws that Test2-Deep's bag did apparently, so some of those need to be fixed, but they have not yet. But for most cases, it will work. Any other questions about comparisons? Okay, moving right along to plugins. So with Test Builder, everything basically got under the test namespace. So you'd have test deep, test exception, test warnings. Test2, we noticed that there's actually a few different categories of testing tools. There are testing modules. There's the tools, like I just showed you, but sometimes there's things that affect behavior. For those, we have plugins in Test2. So you got Test2 plugin, and then what your plugin does. So I'm going to give you a couple examples of plugins that come with Test2-Suite. Bail on fail. This is one of the most requested features for years with Test Builder, and it could not be implemented with Test Builder. What this is as soon as the first assertion fails, you bail out so that all testing stops. That was difficult with Test Builder because your diagnostics were a separate call from your assertion. So if you bailed right after the assertion failed, you wouldn't see any of your diagnostics, which is really awful. There were a few hacks to try and fix that, such as waiting until the next assertion, but then you might have already gone too far and run code you didn't want run. Test2 has a concept of context, which I'll get to later, that makes bail on fail possible. Die on fail, same thing, but you die instead of bail out, which means your other tests will still run. Exit summary is something that's loaded by default when you use v0. It basically puts your diagnostics at the end of the test. srand, this is one of my favorites. This one will seed rand with today's date before anything else is done, so that on any given day, your random behavior is reproducible and predictable, but from day to day to day, it will change, so you still get the test that you're not depending on the random seed. And it will also, whenever there's a failure, it will output what seed was used. So if you're going and looking at a log from a few days back, you can see what seed was used, and you can reproduce that test with the environment variable. This is something Schwarn and I actually cooked up together back with the Fennec project. UTF-8. This is just, if you know you want to use UTF-8, just use this UTF-8 plugin, Test2 plugin UTF-8, and it'll just make everything UTF-8, and you don't have to think about it anymore. Lots of things become UTF-8. Question about the plugins. Okay. There's also Test2 require blah. And these are things where you want to skip a test if a requirement isn't met. Most common one, author testing. So if you've got a test that you really only want to have run when you're authoring the test, then you just use this in that test, and it will only run when the author testing variable is set. There's a more generic version that lets you do any environment variable you specify for the same behavior. Now we get to something that will really save you time that you didn't even know you needed to spend. This Test2 require fork will make your test skip if your system cannot fork. Now you think, well, why is that its own module? Because if you actually want to check if your system can fork, this is the logic you need. That is a lot of logic, and if you don't put that in there, it will bite you someday on some system somewhere. Yes, that took a long time to get right. Real fork is the same thing, except it will also skip if your fork is pseudo fork, like if you're running on Windows. Require module, skip this test if this module isn't installed. Skip if it's the wrong version of Perl. Skip if this Perl doesn't support threads. And once again, to get that right, it's actually quite hard. You can't just require threads and hope for the best. This even catches bugs in GCC versions that cause threads to segfault. Questions about the require modules? Good, we can move on. Mocking. Test2-Suite also comes with some mocking libraries that are based largely on mock quick, which is something else I'd written previously. So let me go back. Mock quick has a different approach to mocking in that when you do mock, you get an object that then controls that mock. Once that object goes out of scope, all your mocking is destroyed. So you don't have to worry about your mocking accidentally leaking somewhere else. If you do a mock with Test2 mock, it will clean itself up when you are done with it. So the control object is what gives you the handle to that mocking. It also lets you change the mocking partway through, and it is what's responsible for cleaning up when you are done. So how do you use it? You capture the control object from creating a new Test2 mock instance. Now, don't look too hard at this because there's actually sugar I'm going to show you that really abstracts most of this away. You tell it what class, what you want to override, what methods you want to add, and then you can override or restore more. You can reset something back to its original, and then you can reset it all when you're done. So tools. There's Test2 tools mock, which provides that sugar I mentioned. It gives you the mock tool, the mocked tool, mock class, and mock object if you want to be really explicit. Mock can do everything, but these other three are there if you really, really want to be clear what you're doing. So you want to mock a class. Capture the control, mock some package, add these methods, override these methods. And this can be a hash ref or an array ref, doesn't matter. And when you call them, it calls the mocked. Once again, return control and you're done. The explicit form would be to either mock space class and then the class, or mock underscore class using that tool. I went a little overboard on the sugar there. Objects. You can mock an object without actually defining a class for it. It will be produced for you on the fly. So you can say, my object, mock, here's the hash that I want you to bless, and here's the method I want you to add for it. And then you can just use that object. Created all the package stuff for you. Is there a question?
Yeah, any problem with this in test class?
Yeah, don't use test class. Sorry, I've got a thing against test class. If you're using test class with a modern test simple, it will all work, and some of these tools will still work if you import them into a test class test, but I'm not verifying that they're all intercompatible.
So it's one or the other.
Maybe. Other question?
Do any of these blow up if the thing you're mocking doesn't exist?
No. Well, there are some things, like if you're mocking a class and you call override and the class doesn't have something to override, it'll tell you that was an error. Or if you go to add and it already has it defined, it'll be an error, because you don't want to try to add something that's already there or override something that's not there. So that will throw an exception. But if the class isn't loaded, it's assuming you want to define it and prevent it from being loaded. And then once your control is destroyed, it will restore your %inc so that you can then load the real one.
Did you chain those mocks, or you mentioned an add, you throw your first mock in, and then you do your testing, and you now put a different variation of a mock?
Yes, yes, and it also keeps it as a stack, so you can also pop that stack and go back to previous ones.
It does prevent it from loading?
If you mock something that's not loaded, it will prevent you from loading the real one until you've destroyed your control object, at which point the real one can load again. Other questions? Okay, now we're moving on to my favorite set of tools, spec. This is based heavily on Ruby's RSpec, which I've never actually used directly because I've never used Ruby, but I really liked what I read about. It's essentially a very advanced form of subtests. It's declarative. It's got some good concurrency setup. So let's take a look at some. So you use Test2 tools spec, and your main keyword here is tests. So test foo, we're defining a subtest, and it passes. Subbar, also pass. Test bad, this one's going to fail. So we're marking it as to do by giving it this hash of params before giving it the sub to run. So this will fail, but it'll be to do. Then you can also do the same thing with skip. Say, hey, we're skipping this because we don't want to wipe our hard drive. And it will skip that. It will not actually run that test block. So it is safe, though I don't recommend you test it too hard. Then done testing when you're done. And yes. In this case, though, unlike regular subtests, these don't run as they're encountered. They get queued as they're encountered. And then when you hit done testing, before it outputs the plan, then it will run them. And it'll run them in a random order. You can change that behavior. You can tell it not to do random, but I don't recommend you do that. So params, there's a few params you can pass into these test blocks. Flat, which means it won't actually render as a subtest. They'll all render inline. To do, skip, we covered. ISO, this one's one of my favorites. It means isolate this subtest, which means on a system that supports true forking, it will fork before running that subtest and then exit when it's done, so that nothing you do in that subtest will affect the parent process. On a system that only has threading, it will use threading to accomplish the same thing. Though I think you have to ask for that now because it was just too buggy, Perl threads, you know. Async is not quite the same. Async means this one can be run in parallel with others, so you could fork to run it, but you don't have to. And you can control how many concurrent tests you have running within the test itself. So if you mark 3 as async, they might all run concurrently. And you can combine any of these. You can put ISO and async together. It's all handy. Describe. A describe lets you group these test blocks. So let's describe color. We'll test red, green, and blue. We'll describe size and test small, medium, and large. And we can even nest describes under describes. Why is this useful? Because you can attach more behavior to these groups. Before all, run this sub. That means it'll be run once before it runs all the test blocks. Before each. This means it'll be run before each test runs. So it'll be run multiple times, once per test block. Anything outside of a describe also applies inside that describe. But something inside a describe only applies to that one and deeper. It doesn't apply to the rest of the file. So this before each will run before red, green, and blue, as will this before each. But this before each here will not apply to this one down here. It's complicated stuff. I'm not going to spend too much time on it because we do have limited time. There's also after all and after each to run at the end of the test blocks. There's around if you want to wrap something around, such as localizing an environment variable. That works kind of like mooses. You get the thing and then you want to continue. Cases. This lets you multiply how many tests you are running. Quite complicated. So in this describe, we've got color validator. We've got a case where C is red, C is green, and C is blue. Then we've got these two tests. What will happen is it'll run red to set C, then run both tests. Then it'll run green to set C to green, and then run both tests. So ultimately, this becomes 6 tests instead of the 2 that you see there, because it's running for each case. Here's what the output looks like. Yeah, I think that's about, I think it skipped some. I should update this slide. Case mods. You can even modify the cases. You can have a before case and after case to modify all your cases. I've not actually had use for this. Mocking. The mocking tools I showed you before work even better under spec, because if you just put a mock in a describe, it will automatically become a before each, and you don't have to capture the control object. If you put it inside a test block, once again, it'll just apply to that test block. You don't need to capture the control object. It'll just work. Though if you did capture the control object, it'll go, oh, okay, he wants control of this, so I'm not going to do that magic. And if you try to do it without capturing the control object outside of this, it will explode and say, hey, that doesn't work. So it's pretty safe. Yes.
When you're defining the mocks, did you put code refs on that, or I guess that's the only way to
There are some shortcuts to not have to do that, but that is the usual way. I don't actually remember what the shortcuts are because I don't use them. Yeah.
If you need more than one set of cases, is it implemented through nested describes?
Yes. So yes, if you need more than one set of cases, you would use different levels of describe. So there is a devil declare plugin I wrote for this that makes this all a lot easier. You can do, if you load test2 plugin spec declare, then you can define your describe block and test blocks as though they were subroutines. You do not need the sub keyword, you do not need the extra commas, and you do not need the semicolon at the end of the blocks. Just looks like you're defining any kind of sub, but instead of sub keyword, it's describe or tests or whatever else. I've used this in production at 2 companies, including where I work now, ZipRecruiter, we're hiring. It's very well tested. It does not seem to introduce any weird syntax errors or any of the weird things that you might be used to using, like, say, source filters or other terrifying things like that. Any questions about spec before I move on? Please use this. Please use this. It's good. Bundles. So there's a couple bundles that come with Test2-Suite, and I want to see how I'm doing on time here real quick. That would help if I knew what time we ended. 12 minutes, okay. So there's the main bundle, Test2 v0, which it will load strict and warnings for you. It'll load UTF-8 for you. You can turn those off. Loads SRAND, once again, the UTF-8. I never covered this, so skip that. Test2 tools, target, pretty cool. Go look up the docs. Exit summary, loads Test2 API. And why don't I have slides that cover that? I should. Anyway, moving on, bunch of other things it loads here. I'm missing some slides. I apologize for that. Test2 bundle more. This one is kind of a compatibility step. If you want to mostly switch to Test2, but your heart's not all the way in it, you can switch to Test2 bundle more. There's still a few things you have to change, but there's a lot less. Like is alias to is deeply. The regular is still just a string compare. But there are a few things that are changed, and the differences are listed here. I'm not going to go through them. And then there's Test2 bundle simple if you are really not interested in doing anything modern, which lets you replace Test2 simple, or replace Test simple. Test simple was so simple, there's actually nothing you have to change. Context objects. This is the magic under the hood that makes Test2 able to do things like bail on fail. It's the primary interface when you're writing a test tool. So this is getting to a more advanced thing. Any of you here who write test tools, this is what you want to pay attention to. So the context object is responsible for tracking the file name, the line number, and any other metadata that you're going to want as diagnostics. And it is your primary way to generate the testing events. Usage. You import the context function from Test2 API, so we're just re-implementing OK here. My OK takes the bool name, whatever. You acquire your context object and you guard it like it is your child. You can call methods to create events. So here we're calling OK with the Boolean that generates the event. And then when you are done, you want to clean up. That doesn't just mean let this fall out of scope. You need to explicitly call release when you are done. That is because this is where the bail on fail logic or the die on fail logic will happen. We can't just have that happen in a destructor because you can't actually throw an exception from a destructor. So the die on fail required us to have an explicit release. But all Test2 tools are going to have this because it's been required from the very beginning. It's not some hack that was added on after the fact. So you know that all your tools, if they're Test2, are going to have this. And Test2 will yell at you very, very loudly if you do not call release and it gets to a destructor. And you return the bool to be compatible with OK. Rules. These are the 10 commandments of a context object. Get it as early as possible. Release it as late as possible. Do not forget to release it. Each sub should get its own. You should not pass contexts around. Do not cache or store the context to use later, though you can clone it and store the clone. Do not share the context. There's a theme here. It assumes it is obtained within a sub, not at the package scope, though if you actually need it at the package scope, there is a hack to do that. Do not alter the context internals, and do not monkey patch the context. No support if you monkey patch the context. Make a pull request. I like features. I'll add it if it's sane. Events. So you shouldn't actually use what was on the last slide to generate OK anymore because I recently revamped the event system. Initially, every type of event or every type of thing you'd want to express with Test2 had a custom event type, and it was actually kind of a pain in the ass, and sometimes you wanted an event to do multiple things. So now these are the ones you should do. If you just want to do a pass, call pass or pass and release if you want to combine those steps, and it will generate an optimal pass object that knows it's a pass and will skip most of the logic, making it significantly faster than using the legacy OK style objects. Fail, same idea. It's an optimized fail, as though that were important. Then any other type of event is going to have custom data, and that custom data is called facets, which we'll cover in another slide here shortly. But here you'd send EV2, that's second style of events, and give it the facets you want. Legacy events are all these. Please don't use them anymore, but here's what they look like. Facets. I'm pretty sure I'm almost out of time here, so I am going to buzz right through these, and not in order. The assert facet is if you've got an OK and you want to make an assertion, give it the name of the assertion, whether or not it passed, whether or not you want any debugging automatically output. Then there's amnesty. This is how things like to-do and skip are defined. If you've got an amnesty facet on your event that also has an assert, then if it fails, it won't actually count as a failure. That is how to-do is done, except it's generic. You can create your own forms of amnesty. It doesn't have to be to-do or skip. Let's see, control gives you a lot of things you can do, like bailout is implemented by telling it to terminate and be global. Parent is used by subtests, not going to go into details. There's plan facet. So you could actually have a single event that has a plan, an assertion, some amnesty, and tells it to exit 0, all that good stuff. Trace, every event should have one of these. There are some cases where it doesn't, but it should. This tells you what stack, like what package, what file, what line, what sub were used to generate the event, what process ID it came from, what thread ID it came from, what context ID it came from, what hub ID it came from, whether or not it's nested in a subtest, whether or not it's a buffered subtest. This is really where all your diagnostics should come from, or a lot of them anyway. Let's see, info is how things like diags and notes and similar are done. And most of the rest of these you really don't need too much detail. Oh, I actually have 5 minutes. Okay, maybe I will go into a few of these. No, I've got a better idea. I'm going to pitch my talk tomorrow. So you have now seen the rich capabilities of Test2. A lot of these capabilities, especially like these traces and all this metadata that each events have, is totally lost if you are using prove and it all gets boiled down to tap. Tap, the lossiest test format ever created. There is something new, and I'm going to be talking about it tomorrow. Test2 harness, also known as YATH. It is a new test harness that also includes the ability to preload your framework or your modules before running the tests. To give you an idea, the Moose test suite on this laptop takes 1 minute and 45 seconds. It takes 42 seconds under Test2 harness when I preload Moose. There are lots of other features. It's under active development, still a little bit experimental, but come to my talk tomorrow if you really want to speed up your testing. ZipRecruiter, our test suite on our sandbox, 4.5 hours. With YATH, 1.5 hours. And cPanel has a similar thing where their test suite ran for an hour, takes 10 minutes. So come to my talk tomorrow if you want to see a test harness that actually puts everything Test2 offers all the way through beginning to end without a tap layer getting rid of all the important stuff in the middle. And if you really care about converting old tests, there's the slides on converting. I neither have the time nor the energy to go over these today, but I'm going to go back here where the link to my talk is so that you can go and look at it yourself. And with that, I am going to step down unless there are further questions. Yes?
Similarly to tests within the blocks where they are randomized cases, are they randomized as well, or are they used as order?
They are randomized unless you ask it not to randomize things, yes. But keep in mind that usually we'll also load the SRAND, so on any given day, it should be consistent every time you run it, but from day to day to day, it will be randomized order. Yes?
Could you display the previous slide while you answer the rest of the questions?
The convert one?
Yeah.
Okay. Other questions? Yes?
You know your not expected reporting for like the deep structures, that's so cool. How do you make that responsive to different screen widths?
So it does actually check and see how wide your screen is, and it will only go as wide as it can, and it will wrap within the cells.
It's all very tiny, teeny.
Yes, but it will
I've
wrap.
got 150 characters in my TTY, and it uses like.
Okay, so that is worth going into. It will wrap, as I said, but it also will make it so that it is explicit when there is a new line. If your diagnostics include data that has a new line in it, it'll do the \n before adding a new line.
It's just easier to read a longer horizontal line than a 10 width on all.
Come to my talk tomorrow on YATH. I think you're going to be quite happy.
Great expectation.
Yes.
He's giving out prizes.
No, I can't promise that. But I am, okay, if you consider a prize being a way to get a complete test log of every single event that was run in its original form and inspect it with the graphical tool, if you consider that a prize, come to my talk tomorrow. Any other questions? Okay, I'm going to step down. Thank you.